So next would be the ability to apply ship-based loads. Maestro has a variety of different load patterns that the user can apply, and you can see, some of the standard plots that you might get along the length of the hull for the weight curve, the buoyancy curve, the net load, as well as shear and vertical bending moment. But some of the various load patterns that we can apply are, say, for the light ship, we've got the finite element weight of the model, and that's basically all of your modeled weight. Once you've created your finite element model and assigned all the properties to it, Maestro evaluates those properties to come up with the weight of each modeled element in there for your structural weight. But of course, that's not going to account for everything. So there's also a mass distribution that can be applied along the length of the hull. And that essentially makes up for all of that unmodeled weight for piping and so forth, so that you achieve the overall mass distribution that you're looking for along the length of the ship. You have the ability to scale weight for a given module or something. If you know it's heavier, say you have a piece of equipment or mast or some structure, you can simply scale the entire mass of that piece of the model. You can rather than adding discrete weight to it, you can scale the existing structural weight to account for something. You can model various cargo as well as things like engines and generators in a couple different ways. Large items such as engines and generators, you may want to add like a point mass and then connect it to the structure using an RBE element to transfer that mass down to, say, the footprint of the engine or generator, or connect it to a modeled foundation that you put in there. For something like cargo, you may want to use like a plate group or something. If it's an area of the deck that's going to be holding cargo, you can define a group of plate elements on there and assign a weight that will get distributed over that plate area. For tanks, you model the individual tanks as a volume group, and once you've got that volume group defined, you can then fill the tanks by defining the density of the fluid that's in there, as well as the percent full. There are other methods besides the percent full. You can also give it the mass and the density, and it will determine, based on volume, how full the tank is. But you're essentially modeling tanks in the sort of traditional sense. You have a volume, and you're just filling it with a liquid of some density. For the hydrostatic loads, you can use either the still water condition or apply a wave of some sort. Now that wave can be user defined, a simple sine wave or toroidal wave, or it could be the effects from the output of like Maestro wave. But that doesn't, that'll more create a load pattern on the pressure pattern on the hull and accelerations and stuff, as opposed to the traditional hydrostatic wave. But you can also apply specific accelerations at or user-defined nodal locations or whatever. Something like Maestro Wave does that automatically and distributes them throughout the ship, with various accelerations on all of the nodes as determined by the hydro code. But the user can also apply individual accelerations within Maestro. There's also the ability to apply pressures to panels. Now some are applied automatically, such as the hydrostatic pressure, or maybe the pressure from the fluid in a tank. But you can also apply manually determined pressures if you want onto a given panel. And then the hydrodynamic, as we mentioned, something like Maestro Wave or an external program could be used to apply hydrodynamic loads to the model, which may include pressures and accelerations. I guess here's a sample of how the tanks might be laid out within the vessel. Each one is color-coded and can be assigned individually how it's filled, as well, the density, as well as the method of filling. The Maestro has some nice export ability, or sort of reporting abilities. This tank volume table is very nice for when you're generating the final report. You get a quick summary of exactly what your tank loads were. And you can have multiple different tank loads. Each one is a load pattern. So you create a different load case, and you can have your tank load out for full load departure, 10% remaining, end of service life. They're all just different load patterns from the same basic model. For the hydrostatic loads, it's just a graphical example of what the still water might look like on the vessel. Now, not all of the vessel is going to receive the hydrostatic loads. There's what are known as the wetted or wettable elements. So you have to define which elements within the model can receive hydrostatic pressure. So here we just have the external shell that's shown as our wettable elements, and then a plot of what that hydrostatic pressure would be from that still water load case. Similarly, if we had placed a wave along the length of the hull, we've got the same wettable elements here, and you can see the deck is not wettable, so and neither is the bulwark on this model, so they're not receiving any hydrostatic pressure even though they may be underwater. And you can see the ship, which has been balanced on that. We can see there's a bit of pitch here because Maestro will do a hydrostatic balance on that wave as well, and iterate to find what the final pitch and heel would be for an equilibrium condition. So for applying the hydrodynamic loads, in like Maestro wave, with the hydrodynamic analysis, some of the included wave-induced loads are based on radiation, diffraction, slamming, sloshing, and green water. All of these are processed to create the hydro load case. For, I guess, when you're running Maestro wave, and this is one of the more advanced features in a separate training, but it goes through all of the different potential wave height, modal period, heading, and speed combinations, and evaluates everything to generate all the potential, I guess, lifetime loads and things. When you select a specific load case to be generated, there's a built-in interface which will map all of that information to the structural model. So once you've selected your load case, basically as a click of a button, it will create that structural load case in the FEA model, and then it's just ready to run for the structural analysis. And you can get your extreme loads, the fatigue. This can be used for helping to determine what your structural safe operating envelope is, or to analyze whipping effects if you do a time domain analysis. And the hydrodynamic loads are, I guess, saved in this ship motion file. Now, Maestro Wave, which is integrated into Maestro, will save the same file, but it could come from an external source if you had another program to generate this file, but it'll be read in. It can be read in and used for processing, or as the source of all your hydrodynamic loads. Now, Maestro Wave, I guess, as we said, is a fully integrated hydrodynamics package. One of the major advantages to this is that because it is fully integrated, you only have one mesh for both the finite element model and the hydrodynamics runs. So it can eliminate some of the error from having to map the loads from one mesh to another. You're also operating just within the Maestro environment, so you're only dealing with the single graphical interface here. It essentially will extract that wettable or the wettable mesh that we talked about earlier, anything that can receive a hydrodynamic load, and it'll use that mesh as your hydrodynamic mesh. In many cases, with the requirements for a lot of these models to be fairly fine nowadays, sometimes that mesh can get a little too fine, and you'll have an excess of elements there. And there are some capabilities within Maestro where you can merge panels together to create larger panels, where some of the more computationally intensive aspects will operate on those larger panels, but others, such as hydrostatic pressure, which are pretty easy to compute, will still be done at the individual panel level. But because you're still using the original FE mesh, it still eliminates many of the interpolation errors when you're trying to use two different meshes for your hydro stuff and your structural stuff. Also, since you're operating on the FE mesh, Maestro Wave can extract additional information from the FE model, such as the weight, center of gravity, gyradius, and so forth. Maestro Wave uses a linear frequency domain 3D hydro panel analysis. It's as we just mentioned, is generated from all of the wet panels and nodes in the model. The source strengths will be mapped directly to the FE mesh, and one of the nice things is that we'll have a hydrodynamic equilibrium by default. The Maestro Maestro Wave will tweak the adjustments, or the force, or the nodal force adjustments. It uses, what's known as quadratic programming to sort of iterate on the solution, but it can put things into equilibrium without the requirement for using inertial relief. Maestro has an automatic load balancing. Before running the model, you'll typically want to make sure that if you're in still water on a static wave or something, you'll want to make sure the model is in balance, in equilibrium. And there is within Maestro the ability to just run a quick hydrostatic balance in there, and it will make sure it'll iterate to find the sinkage pitch and sinkage trim and heel to find that equilibrium condition to put the model in balance, and then all of your loading curves, such as the vertical bending moment, shear, and stuff, should all be in closure. It's also, once you do the hydrostatic balance, it's also a good idea to also just run a quick inertial relief just for any final tweaks, and to make sure that the model is fully in equilibrium. Mainly because for the hydrostatics, you can only balance in the vertical directions where those forces apply. So if there's any tendency to have a side motion, the hydrostatic restoring force is not going to cancel out any tendency to drift to the side. So it can be good to run the inertial relief just to make sure the model is sort of locked in position. So you can do a quick preview check. We saw these plots earlier for the various loads on the length of or along the length of the vessel. The weight, buoyancy, net force, shear, and bending moment. And when the model is in equilibrium, everything should be in enclosure at both ends.